Hello, everyone, and welcome to our Ozobot webinar. My name is Tara, and I am on the education team here at Ozobot.
I'm Cassandra, and I'm also on the education team at Ozobot. Hello.
So, as many of you may or may not know, Ozobot is a great tool for teaching kids how to code and program in the classroom. But if you dig a little deeper into our lesson library, you'll also see that we have a lot of different lessons that you can integrate into your normal everyday lesson plans. That includes math, history, science, and we do have National Chemistry Week coming up here soon. So we wanted to do this webinar to show you some of the lessons that you can actually use with Ozobot that integrates into chemistry, which is something that a lot of teachers don't think about when thinking about Ozobot and coding and programming. So we really wanted to highlight these lessons for you, especially with the National Chemistry Week coming up. One thing I do want to point out is that you'll have a little control panel on the side of your computer screen, and there is a section for questions there. I do have a lot of attendees try to ask questions during the presentation, and we're not ignoring you. We just can't do the presentation and look at that little box on the side at the same time. So if you want to hold all of your questions to the very end, we'll go ahead and open up some time for Q&A, and we'll read your questions out loud and answer them. But just hold off on any of those questions until we actually let you know that we'll be entering the Q&A portion. So without further ado, I'm going to go ahead and pass off to Cassandra, and she's going to go into more depth on these lessons for you.
Yes, so for National Chemistry Week, we selected 4 different lessons to feature, and we featured these on our blog, and so that's what I'll be using as an outline today as I go through the lessons. So before I go to the blog, I did want to let you know that you can get these lessons in our lesson library, in addition to the many other lessons that Tara was talking about. They cover just a wide range of subjects and grades, and so if you're looking for something, check it out. We might have something for you. I think we have about 150 lessons, many of them from educators. So I'm going to share my screen, tell you how to get to the lesson library in case you haven't seen it yet. So I've just gone to ozobot.com, which is our website. Our homepage is populated here. To get to the lesson library, you can go to educators. And then here in this top bar, you can go to click on lessons. And then you'll see our lesson library pop up. If you've never used Ozobot in the classroom before, we have a series of basic training lessons that cover our color codes, which is the screen-free way to program Ozobot, OzoBlockly, which is our visual programming language that uses blocks that you drag and drop to tell the robot what to do without lines. And then we have a deconstruction series, which is a way to introduce a special series that we made to introduce using OzoBlockly. Here's where you can search to find different lessons. So I could just click on here and search for chemistry, for example, or you can just click the search here and see all of the different filters that you can search by. So yes, that's where you can find these lessons and other lessons. I'm going to go to our blog, which is also in the top banner. And you can see we posted today in honor of Chemistry Week 4 lessons for National Chemistry Week. So the first one I want to start out with is called Illustration of the Emission Lines of the Balmer series. This was submitted to us by Dr. Richard Bourne, who has made quite a few lessons for us, and he actually made pretty much all of the lessons that we're going to go through today, which is great. So for this lesson, it is a high school lesson. It only takes about 10 to 15 minutes. So Evo and Bit are going to simulate an excited electron in a hydrogen atom on a map created for Ozobot that contains the energy level diagram for the Balmer series. So here's that map, and then there's a full printout at the end that you can use to give to your students. So on this map, the Ozobot/electron makes transitions from higher energy states to the N2 state. So I actually am going to switch over to the camera. I have it printed out here for you. Here we go. So this is all you need for this lesson. Since it is an OzoBlockly lesson, where it's going to use a program to travel along the lines to do something specific, you do have to download that first. Actually, let me share the screen and show you where that would be. So on the lesson homepage, whoops, back from it, you can see OzoBlockly preview. That's where you're going to get the program that you need to run it along the lines in the way that it was intended. So here's what it looks like. Don't worry, you do not have to program it to do these things. It's already programmed for you and you just access it right there. So you would load the program onto your bot, and we actually do have videos on how to do that if you've never done that before. Basically entails you calibrating the Ozobot to your screen, and then using flashing, you use flashing colors to actually write the program onto Ozobot. So let's go back to the camera. To run the program, I just am going to double click the power button. I'm using bit here. So right here, it tells you exactly where to place the bot. So I'm going to put it down. It's going to give me a few seconds to actually put it on. And you'll see as they make their weight on the energy states, Ozobot's LEDs will actually mimic the color of the visible lines that are actually emitted while making the transitions. And so using this, the students are tasked with calculating their various wavelengths corresponding to the 4 Balmer series transitions. So you can see it's changing. I think you can see. Mm-hmm. So it's actually doing this all based on the OzoBlockly program, and it's a great visual. You can see now it's purple. So that's a really great simulation. And full disclosure, I'm not a chemistry teacher, but the good news is everything that you need to know, I'm going to go back to my screen, is contained in these lessons. So everything you need to tell your students, everything your students need. So even if you aren't a chemistry teacher, I still encourage you to try to bring some chemistry into the classroom. So with that, let's go for Chemistry Week. So let's go to the next lesson. Blog. This is simulation of Boyle's law. So here's the picture for that one, and I actually have the map here. But I didn't skip one, right? I don't think so. So this one is also by Richard Bourne. This is for grades 7 to 12. So for this one as well, you'll just need to load that OzoBlockly program. You need 1 bot per group. I believe for this one, it says bit on the map, but you can actually use Evo for this one as well. But it basically uses an OzoBlockly program to have Evo simulate a gas pressure sensor. The OzoBlockly program, again, you need is there. It'll just open it up. And so, again, it gives you, come on. Oh, well, we'll wait for that to load. But again, it gives you everything that you need, and you would just take it rinse. Ozobot. Never mind. Okay, that one is loaded with the previous program. I preloaded the Evo with this one. So they will study the exact mathematical relationship between pressure and volume under constant temperature. So to run this program, again, just press the power button. You can see it going down. It's going to stop, and that's all in the program. So they basically just collect data from Evo's lights will blink. I wonder if you can see that. Probably when it gets a little closer, you'll be able to see. They're using the top LED's blinking light to collect their data. So you'll see as it stops at the line, it's going to flash a green light, which is equal to 10, and then blue lights, which is equal to 1. So that's how they'll collect the data. They'll write down based on however many times the LED flashes. And then, so that's, they'll think they graph it in this one, but grades 11 to 12 the option to go even further and explore the inverse relationship between volume and pressure through graphing. So that is the Boyle's law simulation. Let me go back. Basically, it'll go all the way down to 0, which I didn't show, but okay. So that one never, there we go. I'll show it to you now. I guess I'll put my screen back on. It finally loaded, but it once again tells you again about the green lights and what those mean, how to run the program, and basically every step. So, and then the formulas that you need. This one, I forgot to mention in the beginning, I'm sorry. They also need the simulation table to keep track of the different data values that they found, and then they'll do several different runs of it just to get the average of it. So, and then here's the graph that they would use. Okay. Let me go back to the blog post. This third one is a very cool activity that we found on Twitter. We reached out to Mrs. Stevens, I think is how you'd say her name, to see if we could share it with you because we thought it was such a great idea. But basically, in this one, their assignment was to choose an element from the periodic table and then code. They used bits, but you can also use Evos to simulate the electrons. So they programmed their Ozobots using OzoBlockly to spin around the nucleus in opposite directions as the electrons in their particular atom would have behaved. So I guess I will show you some of that video. You can always look at it again. So basically, you can see there they are moving around the nucleus. And each student gave a presentation on the different parts of their atom and then, or their element, and then had to run the programs and demonstrate it for the class. So we got actually a bunch of videos of the different ones. So some people did oxygen, someone did carbon. So really excellent way to use OzoBlockly. And in this one, the students are actually programming it. So we love that. And then we also, just for those students who are in elementary school, we, inspired by this activity, came up with a way to kind of age this down. Okay, so here I have made, you could either do simple atoms or just give everyone hydrogen and have everyone do the same thing. But we basically put the element up there, and then you would use two bots if you have them. If you don't have one to be the proton in the middle, that's fine. But basically the idea would be that you would explain that protons don't really move. So that would be the middle of their atom. And then since we have one electron in hydrogen, we would have one Ozobot going around and simulating the orbit. So a good introduction, even if it wasn't in your plans to introduce this for Chemistry Week. In honor of that, it might be cool to just introduce them to this concept by this simple activity that's really easy to do. And this can be modified in various ways as well. But yes, okay. Finally, get my screen back up. We have a simulation of an experiment in viscosity, another Richard Board lesson for grades 7 to 12. This one is going to be bit only. So, thank you. Yeah, rogue bot over there. In this lesson, Ozobot simulates a steel ball falling in tubes of oil with varying viscosities. You can kind of see preview there of what that map is going to look like. For this one, you will also need to load an OzoBlockly program onto the, well, actually several. I'll get to that. But you'll need that map. What's going on? There we go. And then you'll need to print and make copies of, down here you'll see different data tables. So Basically, you'll also need a stopwatch. What have I said so far? So the map, the charts, and the stopwatch, and OzoBlockly to load that on to the robot. So let me go back to my camera. So much switching today. This is what the map looks like. So this one involves 4 different OzoBlockly programs. So I'll just kind of talk you through it rather than have you sit through me loading all of those and demonstrating them. But they first measure the travel times. Basically, the program is going to have it travel along the line, and then when it gets to this tube and goes down, it will travel a certain speed, and then a different speed for green and a different speed for the blue. So these are the tubes with the oils with the known viscosities. So the program is actually going to run it. You're just supposed to run it until you have enough data for 5 different trials so that you can average those. So 5 different trials of how long it took for it to go through the red tube and the green tube and the blue tube. So then they plot those times on a graph, the provided one I told you about earlier, and they interpolate or extrapolate to determine the viscosity of the tube of liquid with unknown viscosity. So they will use one program to run. This is funny. They will use one program to run for these 3, and then programs, OzoBlockly programs 2 to 4. I'll show you those real quick. You'll see here they'll load that one onto the bot and then run it through and take data on that. And then they'll reload it with the unknown viscosity 2, take data on that. And then reload it with the viscosity 3, take data, and then they're able to determine, using the data that they gathered, what the viscosity of the unknown liquid is. So yes, it sounds, everything, again, that you need is in the lesson, all the explanations and everything, if this is something you want to introduce to your class. So with that, I think that we're ready to take some questions if you have any. And I'll give that back to Tara.
Okay, so yeah, if you have any questions, you can go ahead and write them in the little questions box. If not, I'll let you know that none are coming through. And we'll have just a short and sweet webinar this time. I do want to point out that at the after this webinar is over, probably within about a week, we'll be sending out a follow-up email that has all of the information listed that we covered, including the, where to go for the OzoBlog and the lessons. And if you sign up for any of the webinars and aren't able to make it for any reason, all the registrants are automatically sent a copy of the recorded webinar. So don't worry if you're rewatching this and you sign up for another webinar in the future and you can't make it. All of the webinars are recorded and always posted on our website, and they're really easy to access. So with that, let's see. So it's asking if we can show Evo doing the viscosity lab.
Show the first, I can show the first part of it. I think this is the one that I had loaded with the program. So basically, we'll put it on the line, and then it'll go through the red one, and then so as soon as the light turns red, start recording the stopwatch, and then obviously this one's very viscous. Then when the light turns back blue, stop the stopwatch and then record the data for red. Then the next time it's going to go through green. Nudge for that. And then a little less viscous, record that time. And then it's going to go back around to blue. Well, I guess I'll let you see it. We have plenty of time. Okay. So then it's going to repeat that same thing. You want to make sure your battery is fully charged for this one, just so that you can get enough trials in. Don't use any that you use for a different class, and just to be safe. So then, let's see, go back. So then that's the only program, that's the first one that I loaded with the known viscosities, and all the subsequent ones are going to be run in this yellow tube here. So, good.
Yeah. Now, when you had asked the question about seeing it go through viscosity, were you specific? I know you mentioned Evo. Were you specifically interested in Evo, or was it just Ozobot in general? If you could just clarify that so we can help you out with that.
And this one for now actually only works with bit, which I need to update in the blog.
So just to clarify, Ozobot is the umbrella robot, and then there's two models, Evo and Bit. I know people sometimes say EvoBot or BitBot. It's Ozobot, and then Evo and Bit are the two different models. Like Cassandra was just saying, this lesson is specifically for Bit, just due to some of the features that Evo has that would make it a little difficult to work with this lesson. You can see on the front of each lesson, there'll be a layout of the lesson, an overview, any standards that it might meet, which bot that you can use it with. So on the front of that lesson, you're going to see that it's just going to say Bit, and you want to make sure that you're just using it with that model. You can go into the lesson library and search. When you go to the search feature, there is an option to choose between the different models, and if you just have one, you can click on it, and it will bring up all of those lessons that will work specifically with that model. So you want to keep that in mind when searching for the lessons in the library. Okay.
I think just while you're looking, I think these were made by Dr. Richard Bourne before Evo even was released, and so we tested a couple of them to see if they work. So the Boyle's law simulation, that works with Evo, but due to the code, we just couldn't, for now, doesn't work with this one.
Okay. All right, and then you were also mentioning that you do a lot of chemistry with the elementary kids, which is great.
If you have any lessons you want to submit, we would love to get some chemistry lessons for elementary. And so should we go through how to submit?
Yeah, we can share the link.
So to submit, you go back to the lesson library where we were before. I'm going to use our short link for that, ozo.bot/lessons, instead of going through the whole website. So just go back to that lesson library page and go to the bottom. It says submit your lesson. So just take a look at how other teachers and how we do the lessons, where we just want to make sure there are the materials and then the process and maybe even some photos and any necessary materials. And then we actually give $100 to Ozo to go toward our store. So if you have those chemistry lessons, we'd love to see them.
Yes. Okay, and so the last question, which is really relevant, is do we offer certificates or professional development certificates for attending these webinars? And yes, so you have to attend the live webinar to get the PD certificate, but it is available to you if you attended the live webinar. As I was mentioning, after all the webinars, if you had attended or if you registered, there's an email that's sent out to you, and all you have to do is reply back to that email and ask for the professional development certificate. We can check and make sure that you're on the webinar and how long you were on the webinar, and then we can send out the certificate for you. So that's definitely possible. Just look out for that email. That will be coming out shortly. So that was all the questions that we had. So thank you for attending this webinar. Look for that follow-up webinar soon, and you can also watch a recording of this. It's posted on our webinars and PD section of our educator section of the website. So thanks for attending. Hope you found some interesting lessons, and we look forward to seeing you on the next webinar.